Okay, so to work on the first problem from homework 10.4 and 5, it says a right-tailed test with 12 degrees of freedom. You have to consider a couple things first. So let's look at what right-tailed, left-tailed, and two-tailed means first, and then that might help make sense of it. Right-tailed would be anything that looks like this. We find the critical value, and then everything to the right of that is what's considered. And so that would be the right-tailed. Left-tailed would be if a value was picked and everything to the left of it was what was shaded. And then finally, two-tailed is when the following happens. You have a left-tailed and a right-tailed, but they're symmetric. So you can treat them as symmetric. So what you're going to do for this is we've got a right-tailed test with 12 degrees of freedom and alpha being 0.05. 0.05. Degrees of freedom is 12. And all we need to do now is just look on this table for the one that matches that. So notice that it says at the top these are right area to the right, so that's right-tailed. So we look at 0.05, that's here, that's this column. And we look for 12, and we get 21,026, and you'll notice, oops, that is exactly what I put as the answer, so that's why that one worked. The next one, we've got a left-tailed test. That changes this because all of the values on the table are right-tailed. And then they give you n instead of the degrees of freedom. Well, luckily, it is not difficult to find the degrees of freedom. So if n is equal to 22, then the degrees of freedom is equal to n minus 1, which is equal to 22 minus 1, which is equal to 21. So we've got the degrees of freedom, and then alpha is equal to 0.05. Then this means that the confidence level is 0.95, and so we're going to use 0.95 on the table and 21 and find that value, and that's what will give us that answer here, 8.897. So if we look, we go to 9.5, and then we go to 21, which would be here. Actually, I made a mistake. 21. Oh, it's 0.01. My mistake. I did make a mistake there. Let me erase this. Sorry about that. Sorry, I had the wrong alpha. So we have 0.01. Well, what makes a dollar with 1 cent? Well, that would be 99 cents. Sorry, and that will correct that mistake I made. So if we go and look now, we're looking at 99, that's this column, 21, 8897. And so you can see that we've done it once I figured out that I had made that mistake. It was real simple to figure out. And then finally for the two-tailed, this one's a little bit different. So we've got n is equal to 30. So then df, the degrees of freedom, is actually 29. Okay, so we need that. And then one other thing is we have alpha is equal to 0.1. Well, the reality here is that we're doing two alphas, right? We're doing one on the left, one on the right. So we need to split this evenly. We have alpha over 2 is equal to, if that's 10 cents, 5 cents is half of that. Okay, so that's alpha over 2. So if you want the right side, alpha over 2 is equal to 0.05. This is your actual alpha in this case. Okay, that's one we're going to use with the 9 degrees of freedom. So if I use that and 29 degrees of freedom, this is the right side. And then if I use alpha over 2 equals 0.05, that means 5%, then sea level is 0.95. And then we have the degrees of freedom equal to 29 still. So we use these two, and we'll get the left side. So if we look on the table, we should get 17,708 and 42,557. So we look for 29. This is 9.5 right here. So 29, 17,708. And then we look for 0.05, that's this one. And 29, 42, 557, and that is how we go through finding those values. Those are the critical values for this table that we're looking at. So that's the first homework part. I will make other videos for the next parts. Thank you for watching.